In previous lecture, we studied how plant breeding can be used to develop disease-resistant varieties. Same way, plant breeding can be used to develop the pest-resistant varieties. So pests are also creating a lot of lowering of the crop production. So these plant breeding techniques are almost the same. The most important concept is collection of the germplasm of cultivars which are resistant for pest. For that, we have to study the crops in terms of their morphological, biochemical and physiological properties. For example, hairy leaves in cotton makes it resistant to acids. Same way, hairy leaves in wheat makes it resistant to cereal leaf beetle. Smooth leaves without nectar in cotton makes it resistant to borer. Then solid stem in wheat makes it resistant to sawfly. Likewise, in maize, high aspartate, low sugar and low nitrogen content makes it resistant to stem borer. So likewise, so many types of physiological characteristics can be identified, and based on that, pest resistant varieties can be developed. Here is a list of few. For example, Pusa Gaurav, a variety of mustard has been developed which is resistant to aphids. Pusa Same 2, Pusa Same 3 are the varieties of flat bean which are resistant to acids, aphids and fruit borers. Same way, Pusa Savli and Pusa A4 are the varieties of bhindi which makes it resistant to shoot and fruit borers. So we can see that because of these plant breeding techniques, we have been able to develop the disease resistant and pest resistant varieties which have made it possible to minimize the use of bactericides, fungicides or pesticides. So this plant breeding method is really helping us to increase the crop production and reduce the pollution. Now we will take up another very sensitive issue, that is of hidden hunger. Today, more than 840 million people lack daily food and more than 3 billion people are suffering from a phenomena called as malnutrition due to hidden hunger. Yes, they get the food to eat, but that food is showing the deficiency of micronutrients, proteins and vitamins. Because these people, because of poverty, have got the food to eat which is only rich in carbohydrate like maize, wheat, rice. These foods lack micronutrients, proteins and vitamins. As a result, these people, they show so many deficiency diseases and it makes them vulnerable for other diseases. So this hidden hunger can be dealt with using biofortification. Yes, biofortification is a process of fortifying the staple food to increase their nutrient quality. So the crop is made to be rich in nutrients. Very good example is Atlas 66, a variety of wheat. When it was crossed with native wheat variety, a biofortified native wheat variety was produced, which was also very good and rich source of protein. Likewise, many other varieties like varieties of rice were developed which were 5 times more richer in iron as compared to the normal native variety. In the same way, the variety of the corn was developed which was 2 times richer in amino acid as compared to a normal native variety. In this direction, IARI, that is Indian Agriculture Research Institute, New Delhi, has done a lot of research and released many biofortified food items like vitamin A enriched carrot, spinach and pumpkin, vitamin C enriched tomato, mustard and bitter gourd, and protein fortified beans and peas were released. So also iron and calcium fortified vegetables were released. So this biofortification has been really very effective tool to tackle the hidden hunger to a large extent.